I'm Yossi Elran. Here's a bit about what I do. I work at the Davidson Institute of Science Education at the Weizmann Institute of Science. We have 72 science and math education projects with over 300,000 participants. Some of these I'm in charge of the recreational math projects, such as the Math by Mail, where we have 4,000 participants online in a yearly course for recreational math for kids in Hebrew, Arabic, and we're just starting in English. I organize the Celebration of Mind and annual National Recreational Math Conference and other stuff. So, can John Conway, Retrolife, the number 11, and the mathematical magic trick be coherently addressed in 6 minutes? Because according to the mail, I understood we have to address all of these issues. And so that was the question. Thank you very much. I will try, actually. 2 years ago, I was about to give my speak about the game of life, and John Conway was just before me, and this is a quote from him. But I'm still going to speak a bit about the game of life. This is a board about the game of showing the game of life. A few years ago, I introduced it as a puzzle, where the puzzle is given a certain configuration of the game of life. What is its previous generation? Giving some extra restrictions. We rephrased this as the following puzzle, which is much more straightforward. We have to surround each white token on a given board. So here you have just a solution. And we have to surround each white token with t black tokens. In this case, each white token has to be surrounded with exactly 3 black tokens, so that each black token is not surrounded by 2 or 3 other black tokens. You can notice here the black tokens here have either 1 or 0 neighbors. They can have more, but in this case, you're not allowed to have 2 or 3. And no empty square on the board can be surrounded by 3 black tokens. And here's the puzzle and the solution. This has been generalized to use different sets of rules, also different topologies with the theme of number 11. So here we have it on a hexagonal board. And this is my in my gift exchange paper, and the Roman 11 on a Go type board. And another generalization which we have is 2-player Retrolife, where the players decide on a shape to make with white tokens. So you can see here a white token shape. And then players take turn putting black tokens, which will create the shape. Now the player who places the last black token, which will create the shape, using the restrictions I said before, is the winner. Now, it's not as simple as it looks, because the last player, a winner can make the other player not win in the next move by adding black tokens other places and making all kinds of structures. So here, this is a winning move for one of the players, for the next player, and your task is where should he put that black token to win. So all the black tokens will, if you put the rules of the game of life, all the black tokens will disappear and you'll get back to only the white shape. So we've done the game of life and evolution simulations. We've spoken about generating puzzles. Can there be a generation of a class of magic tricks? Well, the answer is yes. And here is a pyramid magic trick, which was introduced by Martin Gardner and further spoken about by Karl Mackay. It can be done with cards, it can be done with numbers. Here's the magic trick. Spectators shout out 10 numbers. And the magician immediately predicts, he says, I'm going to do an amazing mental magic trick, and you're going to get the number 9. So he looks at this row, and he says, well, I'm going to tell you how I did this magic trick. He says, every 2 numbers I summed together. So 2 plus 7 gives us 9, and 7 plus 8 gives us 15. But 15 is larger than 9. Any number which is larger than 9, we sum the 2 digits together. So 1 plus 5 is going to give us 6. 8 plus 3 is 11. 1 plus 1 gives us 2, 3 plus 5 gives us 8, 5 plus 6, again 11, so we sum the 2 digits together, 1 plus 1 gives us 2, 6 plus 2 is 8, 2 plus 0 is 2, 0 plus 3 is 3, 3 plus 1 is 4. So now we get 9 numbers in the row, okay? And we do this again, we get 8, and then 7, and 6, and 5, and 4, and 3, and 2, and 1, and the predicted number appears, number 9. So how is this done? Well, the magician, all he has to do is look at the first row and take the red numbers, the 2 and the 1, and sum them together, gives us 3. And then sum the black numbers by multiplying each of them by 3. So 3 times 3 is 9, and 2 plus times 3 is 6, and 9 plus 6 is 15, plus 3 gives us 18, and 1 plus 8 is 9, and that's how he predicts it by doing this kind of calculation very easily just from the last row. Now, we can start with any row. However, all the other rows require a combination of all the numbers in the row, so it's a bit difficult to do this mentally. But if we look at what the coefficients are needed, giving the numbers of rows, here we have up to 40 rows to do this trick, and we chose the 10th row, which only has 4 colors in it. Doesn't it give a nice fractal shape, this? And so the 10th row is the row which has 1, 0, 0, 3, 0, 0, 3, 0, 0, 1, which are the coefficients for the last row. After that, you get 28. And I'm referring you here to an article by Behrens and Humble in the Mathematical Intelligencer, who shows this for the case of moduli 3. And so finally, if we take a look at the fractal for modulus 10, we get a neat magic trick for the G4G11. There are 11 numbers in the row, and this works exactly the same, and this can also be generalized. So here's the pyramid magic trick, modulo 10 with 11 numbers. These are the 11 numbers that the spectators shout out. And here the math is just to keep the units digit and throw away the 10. So 10 plus 2 is 2. You get 12, but you chuck away the 1. So you get 2. 2 plus 7 is 9. 7 plus 8 is 15. You keep the 5, chuck out the 10s, and so on. And here the magician is going to predict the number 6, which incidentally is the number that he gets to, and these are the coefficients. The numbers in red are times 1, in purple times 5, and in green times 2, and thank you very much. In 6 minutes.